My name is Alexandra Kemper. I am at Microsoft, the PM for the C++ extension for VS Code.
And hi, everyone. I'm Sinem Akinci. I am the C++ cross-platform and CMake product manager for both Visual Studio and VS Code.
Mm-hmm. Okay, let's get started. So in terms of collaboration, why are we even talking about it? What is happening? And the biggest elephant in the room is everything has fundamentally changed in the last couple of years because of the pandemic. This is not a surprise. We were all here for it. We all saw the change. And especially in terms of where people are working, we've kind of had to redefine collaboration because, as you can see from the Stack Overflow developer survey, which you might be familiar with, these are the results from 2022. So in 2022, 85% of workers have at least partially a remote workspace. So they're either hybrid or remote. And from what we could see, it was pre-pandemic, it was roughly 19% of workers. And this is a dramatic shift. And obviously these are general, this goes across different size companies, or for example, they found that for smaller companies, they tend to be in person. For large companies that are 10,000 plus people, they tend to work in more of a hybrid setting. But no matter how you look at it, even if these were estimated numbers, a roughly 65% shift in where people work, how they work, is going to cause some sort of changes in how they try to effectively work together. So the question is, how has this affected collaboration itself today? And this is where we looked at a bunch of different research that have been done. And Microsoft actually spent a lot of time trying to research this in 2020 and 2021 of how do people feel about this? And in the feelings overall were not great. Overall, people felt more siloed. They felt disconnected from their coworkers, especially also if they were a new coworker joining a group. They felt like it was really hard to reach out to someone and kind of establish a personal connection, especially if you're just in Scrum once a week and you're just state your report and state what you've worked on. And then it's really hard to even make small talk because you don't know anything about your coworkers. Also, there's a decrease in the direct communication. That's people, you walk past someone, you see, oh, wow, they got a haircut, and you can make a polite comment on it, and there's an increase in kind of this indirect messaging where it's really hard to tell what the tone is that might not come across. And so with all these different factors combined, they found that it's much harder for new employees to build a support network in the first place of people where they feel connected to a culture that they enjoy. And also it's harder for employees to acquire and share information. It's a lot harder now. Instead of just walking past someone's desk and chatting with them, you need to make a meeting potentially, or you don't even know if they'll be at their desk because so many people are working in kind of a hybrid setting. So this is where there's been a lot of, based on the research, it's been a lot of negative points, but also that doesn't mean that there are no perks so far. Because with hybrid work, you are not commuting, which I can personally say is sometimes a huge blessing. For me, it's a 40-minute one-way commute, and I'm glad that's not a thing anymore, or only when I want it to be. So you can spend more time with your family, you can spend more time doing hobbies. You can also kind of pick your work hours more, because if you, for example, have a globally distributed team, then you can work more in your own time zone, or work around, like, for example, what your family's like time limitations are with bringing the kids to school or picking them up, things like that. And what we found is that on my team, on Sinem's team, in our division, that people were really enjoying hybrid work, but there were a core kind of requirements that they needed to still be able to share and discuss code as if you're sitting together, which is difficult if some people are remote, some aren't, and it's less predictable where people will be. And then also that if people can still work on interesting projects that they, for example, were not able to spend time on before. So all of those tools can be necessary. And over time, we just heard more and more and more issues around this whole how we can share code, how we can talk about code. And we heard this from our own division. We heard this from all of our users saying, hey, this has gotten a lot harder in the last couple of years. How can I make it better? And so from these developer issues, we kind of had a lot of broad categories we could categorize it in, because there were a lot of new hires, or a lot of people very frustrated with the new hire process, because I can tell you every time I've joined a team, there's always a getting started walkthrough. It's always out of date. Nobody's updating it besides maybe the last new hire who was here a while ago. And this is the whole process of how to set up your machine, how to access your team's code. Then you actually get into the code and you notice, wow, people have been building this for a long time. How do I even know what they're doing and where they're coming from? And it's usually very messy. And then you have to start contacting people, and you find out about all these edge cases. And this just gets very complicated and also frustrating for a new hire, because there's so much to learn, so much to figure out that's potentially not intuitive. And there are not a lot of up-to-date docs for them to reference. And then on the side of the experienced developers on the team, their issues around collaboration usually were more, oh, I need to be able to collaborate with a new hire, for example, to explain a topic to them, but I don't know whatever their newest setup is. Or, for example, we're using different IDEs because I've been coding in this IDE for at least 10 years, and I don't know what someone in a different IDE is doing. And so they have very specific setups that they are focusing on, but need to answer a lot of questions. But the questions they ask themselves tend to be more niche. Obviously, they're building more complicated products. And so these are questions that probably you can't potentially ask someone, or if so, you're brainstorming and then trying to reference documentation. But at the end of the day, in order to work together, both of these employees are going to be collaborating on code reviews. They're potentially pair programming. They need to manage this code base that they're accessing together, and kind of discuss it and find ways that are effective for everyone involved. And so the question kind of becomes, okay, we have these completely different type of developers. How can they collaborate? And so we've spent the last couple of years building a lot of more tools around this. And we kind of found, okay, here are a couple of major problems that a lot of teams are running into. How can we make these better? And what tools can we use? So we need to find a way to streamline the new hire setup, because this is just usually out of dated. And so we need to get tools for setting up a machine, accessing a code base. We want to minimize the amount of repetitive work people are doing to maintain their code bases. So you don't need to, for example, rotate access keys manually. And then also we need to find what type of tools can people use to share code and review it together in a way that's effective for them and works in both, hey, I'm going to call you and we're going to review this together, or just do it in whatever time works for you. So let's start at the beginning with streamlining the new hire setup.
All right, so I think we can all relate to being a new hire at some point, and like Alex said, going through that outdated wiki, or for some reason, some weird error is appearing on your machine whenever you're setting up your IDE for the first time. And this creates a big pain point for a lot of developers, and it's easy to break your system. It's easy to misconfigure it. And overall, it's really easy to end up in a non-consistent developer environment, which creates a lot of downtime, especially when you're spinning up a developer environment for the first time. If you think it's annoying to set up a developer environment for the first time, you're not alone. The ISO C++ Foundation survey found last year that 70% of developers report setting dev environments up as a pain point. This put it in the top 5 pain points that this survey even found. So clearly this is something that's hitting C++ developers across the board, especially C++ being a language where there's a lot of obscure dependencies at times. So despite this being a pain point, sometimes the traditional solution would be to use a VM, but there are a lot of downsides with using a VM for setting up your code base. The first is that it is difficult to set up because you still have to go through a lot of those manual steps of installing your compilers, making sure your IDE works on it. And they are also difficult to maintain because you have to have a whole IT team supporting it, and you have to manage it through a VM manager, and they can be isolated from each other and not connected. And they also are potential security vulnerabilities because you have to do a lot of that manual configuration to ensure that this VM is secure. So we have a few tools that help alleviate a lot of these pain points that come with traditional VM management and setting up a dev environment from scratch. The first is GitHub Codespaces. And what GitHub Codespaces is it's a cloud-based IDE. It has the compute power of an IDE, but it's hosted on a browser, and it's just powered by a Linux VM. And so it allows you to spin up a cloud-based IDE on any of your GitHub repositories very simply, and it alleviates a lot of the compiler acquisition, and a lot of the times code just works in the code space. And it's a few simple clicks to spin up, and it's a really great solution for anyone who's either trying to contribute to a repository for a scale of weeks and weeks, or anyone who's even just trying to review a pull request and they don't want to set up their developer environment to ensure that they have all the right dependencies managed. And it works with any GitHub repository. As you can see, all you can have to do is navigate to that code icon, and there you can see all the code spaces you have, any that are currently active and running. You can use this view to stop code spaces. You can use it to delete code spaces, and it allows a lot of easy, simplified management of your code spaces. And so reviewing what's really great about a GitHub code space is that everyone on the team has an identical developer environment, which includes having the same tools and libraries because you are all creating a code space on the same repository and the same files. So this is going to create a consistent developer environment so that I'm not the new hire that's hitting these obscure issues. We're all having the same build environment together, and we can get to that productive work quicker. It alleviates a lot of the issues required that happen with installing compilers and extensions locally. It's all hosted on the cloud and directly connected to Azure. So it alleviates a lot of that manual work as well, and following a manual wiki and maybe skipping a step. And it's created within a few simple clicks from your GitHub repository. So anyone can do it, and anyone can contribute to your GitHub code space that has access to your GitHub repository. So it's really great in this way, and we can walk through an example of how simple it is to set up a GitHub code space. In this case, you'll see I have a forked branch of Open Roller Coaster Tycoon 2. It's a complex C++ project with a lot of dependencies, and it is a CMake project. So it'll take about 60 seconds to set up the code space, but I'll walk you through how easy it really is. So you just go over to the code button and create a code space on this branch, and it'll spin up the code space. And what's great about it is, as you can see, it's spun up within a few seconds, and you're looking at a VS Code instance in a browser. And so this has a lot of the compute power of VS Code if you had downloaded it locally. So you'll have IntelliSense, you'll have find all references, you'll have a lot of the great power behind VS Code and an IDE downloaded on your machine, but you don't have to go through a lot of that acquisition and making sure that your code base runs locally. So it's a consistent developer environment. And now that you saw it spun up within 60 seconds, all you need to do if you want to customize it further is within VS Code, there are the command palette, and you'll add dev container configuration files and create a new configuration and select the language you're developing in. In this case, it's C++. And then the Ubuntu version. In this case, we'll just choose the latest and the CMake version. There's also a bunch of additional features you can install. In this case, we just want a clean developer environment, so there's no need to install any additional features. And this will create a devcontainer.json file. And there's a lot of documentation available on this online if you want to customize this. But some things to call out is you can specify commands that you want to run in the command line after the code space is created. And you can also specify any sort of VS Code extensions that you want it to download after the code space has been created, so that you have all the tools you need to succeed with your code base. Then it will also create a Docker file, and here you can specify different Docker commands, the main callouts being any library dependencies that you would need. And this can be a little bit of a manual process, but all one developer really needs to do behind the scenes is list any third-party dependencies in the Docker file that your code needs to build, and list any additional extensions we want to use in the code space. So what we recommend with C++ development is definitely the C++ extension and CMake tools, but we also recommend the Docker extension since you're working with a Docker file, and live share if you want to call in any coworkers to help you fix a bug. And only one developer needs to do this setup, so that any developer can then single click to create a code space, and everything just works with compiler acquisition, any third-party dependencies you may have, and get straight to work. So they just need to commit those files back to the repository, and that way anyone can create that consistent code space on it. So we'll take a look at a finished code space. Here is the Open Roller Coaster Tycoon 2, but with a completed Docker file and with a completed devcontainer.json file. And as you can see, the configuring has completed, the generating has completed for the CMake project, and we have a slew of additional packages that this code depends on. And then in the devcontainer.json file, we have specified the extension IDs of the different extensions that we want it to download. And if you can even see on the left-hand side and along the bottom of VS Code, a lot more information is populated from the C++ and CMake tools extension, as well as icons for the live share and Docker extension, if you're familiar with VS Code. And so Code Spaces is a really great tool to really get you to that one click. But some things to consider are it is powered by a Linux-based VM. So your code base does need to work with Linux, and it is constrained to repositories hosted on GitHub right now. So if you have a private repository, you won't be able to create a GitHub code space. The other thing is that when you create it through the process that I walked you through, so from the browser, it is going to use VS Code as the editor. The thing is that there is extensions for GitHub code spaces in other IDEs. So there is an ability to use a code space in other IDEs, but if you want to have that browser experience that is the simplest, it is going to default to using VS Code as an editor. And so Code Spaces is great because it provides compute power with a GitHub managed VM. But is there a tool that lets me run my code in any container environment so that even if my repository isn't hosted on GitHub, I can run my code and configure it a little bit more? This is where Microsoft DevBox comes in. Microsoft DevBox is a little bit more customizable. It provides pre-configured project and task-based dev boxes that are hosted on the cloud. And these have network resources and other tools already integrated. They provide ready-to-code, project-specific cloud-based workstations that are centrally managed, and they allow for complex scaling between projects and easy setup of actual dev machines. So the setup, as you will see in the coming slides, is a little bit more convoluted, but it allows for that layer of customization. And then any developer can spin up multiple dev boxes for any of the different needs that they have that are independent of each other. And this is all super simple. So you can customize the configuration of these dev boxes to support every developer on the team with the tools and resources they need to succeed. And since this is a shared environment that has been set up, you can share code, access data, and collaborate using a shared environment. And this is all going to be, again, ready to code. So all of your code base will be loaded onto this Microsoft DevBox, and everything will just work for any developers that are trying to spin up a Microsoft DevBox. So to sort of walk you through how a Microsoft DevBox is set up so you understand the different teams at play. First, we have the IT teams. And what's really great about Microsoft DevBox as compared to talking about GitHub code spaces is there is a really layer of customizability with setting and managing security policies. So they can manage network configuration, security settings, organizational policies. Then once they set those security policies, dev teams will create pools of dev boxes tailored to the developer's projects and tasks. So they'll configure the dev boxes by project. For example, if they have any cost allocations that they want to set up, or if they have any dev experience settings that they want to set up, or dev box SKUs, they're able to configure that and set up that dev pool for then developers to spin up dev boxes on for their current tasks or projects. So for example, if I need a high compute workspace, I can spin up a dev box for that. And then, I need to do some data analysis, I can spin up a separate dev box that is independent from that for the data engineering work. So now we'll walk through how a dev box is configured in real time so you can take a look at it. So Alex is gonna walk us through the process of this.
Yes, okay, and so this is where, you see 8 steps on the right. Don't get worried, let's pause it for a second. And before we start going too fast, just kind of create an overview, because as we said with CodeSpaces, this is a super quick setup. Dev boxes is not quite as intuitive with just a one quick click solution. So stick with me here for a second. And this is where, out of the 8 steps you see here, probably I would say the first 5 would be something that an IT admin, and someone organizing this for an entire company would be doing, because a dev center is just like an all around encompassing project that is just used to organize everything. And you would maybe have like one dev center for an entire company. And so that you need to create this dev center, create the virtual networks, and create the network connection. So let's take a look at that. And so let's see it in action. Okay, so what we're doing here is we're creating the dev center, which will be for the entire company to help define what types, to just help manage the dev boxes and define what type of dev boxes we will have. So this is not the part where we start selecting images. This is just an all-around organizational level. And now I have sped this up for a little bit, so we don't need to sit here for 5 minutes looking at the deployment screen. And magically the deployment suddenly finished. Who would have thought? So as you can see, the Dev Center contains all the projects. It contains all of the network connections, which we don't have any yet. So this is what we need to set up next. And we need to create a virtual network, because this network, this virtual network is then going to be connected via a network configuration to our actual dev pools, which contain the actual dev boxes, because that determines what type of join the individual dev boxes will have to join your Azure AD domain. So now we're just waiting for the virtual network to be created, which is much faster. So deployment is complete. So now we need to create the network connection. So this is where we're on step 3. And the network connection also ensures that whatever Azure region you're building your dev boxes in will be in the same place as the virtual network. So this is just going through the create flows of the network connection. But this way, for example, if you have multiple network connections, you can say, oh, I want this specific, different types of dev box to be made in different regions. If you're have multiple developers in different geographies and you want to optimize which Azure regions they're using. So we're quickly deploying the network connection as well. This is where I think we jump into the future really quickly again. But by 2 minutes and 23 seconds. I tried to time it exactly to give a feel for how long this would take to do. So this is still what an admin is doing. And now we get to the part where we need to now link it together. We need to tell the Dev Center that a network connection exists to our virtual network. So this is just really quickly under the networking blade. Well, we first need to navigate to the Dev Center. And then under the networking blade, you can just add your network connection, which is still pretty straightforward. And that's where we also decide that it's going to be the Azure Active Directory join. So all new dev boxes will be Azure AD joined. And now we need to create a definition. The definition is the most important part, I would say, because this is where we can decide what type of images we want to use for our dev boxes. So as you can see, you just put in a name, and then you can choose from different images. And this is where it supports, if we could pause here really quickly. As you can see, I'm choosing the Visual Studio Enterprise on Windows 11 image. So this is a pre-built image. You can get it to Visual Studio, and it is Windows 11 plus a bunch of different Microsoft 365 apps. It includes Visual Studio, it includes Visual Studio Code, and this is where you can also upload your, you can add your own custom image. For example, with your specific code base or your specific source code, whatever you want to use to fit your needs. And this can be done using the Azure Compute Gallery. And so this is where you can see that we're choosing an image. We can also here choose, what we're going to do next is choose the image version. And the image version is really interesting because this decides the version of the image that every single person within that pool uses. And here, if we could pause again really quickly. Before we press create, exactly. So you see, we picked an image, we picked a version, and I chose to do the latest, so it will always pick the latest. However, if you have some sort of security vulnerability, this way you can decide every single dev box created in that pool is going to be this specific image version, which from an administrative perspective, just makes it a lot more secure. You can also choose the compute amount. And because this is billed by compute, it is nice that you can actually set caps here, and you can also set cost caps separately of how much people are spending. And then whatever storage size each individual dev box will be. So so now we continue. And now that we've created the definition, we now need to create the individual projects. And this is for, like, as a team lead, you would join in. It's already been predefined for you what type of project you would have. And it's been predefined for you what type of definition you would have, and you just create a project for your specific team. So this is me creating one for my C++ team. And within this project, you can have multiple different individual dev box pools, and you can also say, oh, these are the types of definitions I want to use, which then determine what type of dev boxes are able to be created in the first place. So, And if I did not time skip, if there's not a time indicator, this is still in real time in terms of how long it actually takes to deploy everything. So now we have a project per team, and within that project, we can create a pool. And so this is, so as a team lead, all you would do is just create a project and then create a lot of different pools within that project. And then as a user, you would never see any of this. You just go to a developer portal, click on it. It creates a new dev box for you, and all the requirements and tools that are included are already there. And so, for this dev box pool, you can also automatically stop any dev boxes from running after a certain amount of time, for example, at the end of the workday. And you can also decide whether you want to feature their addings automatically hibernating users. And so, and finally, you just need to give individual users access to this specific dev pool. So this is where you can see me saying, okay, I want to give this a specific role, which means I'm giving access to the dev boxes to Sinem. So I just select her, in this case, email from the list and give her access. And now I'm pretty much working as a team lead, and Sinem is a developer on my team, so she could easily just access this, create a dev box, and be ready to go. And so so this process is a lot more, it takes a little bit longer than setting up a code base. However, it gives you a lot of flexibility to actually choose what images are used, what type, like how to limit what can be created, what can't, and which tools are included. And there is an idea that in the future, one of the planned They have different features planned around which tools can be selected, which tools can't be selected, and what is automatically included. But worst case, you can always do a custom image. So this was talking a little bit more the process of actually creating a dev center from the admin side. But now I give it back to you, Sinem, to continue talking about dev boxes.
Yeah, thank you. Yeah, so as you saw earlier, they do take longer to deploy. So as compared to GitHub Codespace, it's not 60 seconds, but it is. But with that, you have a lot of those customizations, as Alex kind of walked through. You have a lot of that added security. You have that added allowed like system settings. So these are just some things to consider with Microsoft DevBox. These also are going to spin up Windows-based DevBox, but you're able to have cross-platform compatibility by just having Visual Studio and, for example, using WSL. And so there is cross-platform functionality. It is just going to be a Windows-based DevBox out of the gate. So it's just another thing to consider. And for that longer-term development, you just need to know that to access your DevBox, you are going to need to maintain an internet connection. It's going to be on a cloud connected device. So it's just something to consider. You can't do offline development with the Microsoft DevBox. So now that we walked through two different tools that sort of help streamline that new hire setup, eliminate a lot of those manual steps, ensure consistent developer environments, which tool should I use? Well, it just depends on the level of constraints that your team has. For example, do you have any IT policy constraints? For example, you want to prevent devs from having root access and you want to customize that. If you do, you're going to want to go with the Microsoft DevBox, but if you don't, you can go with a GitHub Codespace because any dev can have root access to your GitHub repository. The next is, how long are you working on this project for? If this is going to be years and years, Microsoft DevBox is a great long-term solution. But if you're just trying to spin up onto something very quickly, maybe work on it for a few months or just do a pull request, GitHub Codespace is a great way to get up off the ground very quickly and get coding. Also, do you have any OS constraints? These aren't necessarily constraints, but just things to consider. And it's that GitHub Codespace is a Linux VM. So your code base has to run on Linux, but the Microsoft DevBox is Windows-based. Although, again, if you are targeting a Linux system, you are able to do that. So it's just things to consider what you're more comfortable with. These are both great tools for eliminating a lot of that inconsistency, easy to break dev environments. So now that we've set up your machine, let's find a way to build and configure your team's code on your new machine. So the machine's set up, the code's there. Now you have this 22-step wiki on how to build your code. In this case, it's a CMake project, and you have these convoluted commands, and you forgot the command, and you skipped a step, and now your CMake code is not building. This creates a lot of repetitive work and a lot of ability for you to break your build again. So keeping track of these commands can be a pain, especially build, configure, and test commands. And if you think managing CMake projects is quite difficult, you're not alone. Nearly as many people who complain about setting up a developer environment, 67% of developers reported managing CMake projects as a pain point because of how convoluted these commands can get and ensuring that your build succeeds. So this does not have to be a huge pain point, especially if you are utilizing the right tools from CMake. Kitware does a lot of development to ensure that you can have consistent environments in CMake and are constantly iterating on solutions. So this is where CMake Presets can help. So CMake Presets basically is a JSON file where you can store any of those configure commands, build commands, test commands. They're adding support for a lot more too. So you can specify those all in a JSON file that you commit to your CMake repository. And that way, anyone who is working on your CMake repository can pull the code and have all the CMake presets in a centralized location, ensuring a consistent build environment across any IDE with just a single file. So it's really great. If you look at this example, for example, there you see an example Windows-based CMake configure preset. You're able to specify Linux-based configure presets, Mac OS-based configure presets, and there's a lot of customizability. There's a lot of documentation online. Again, you can add so many different commands to these configure presets or build presets, but this is just a baseline skeleton of what they would look like in your CMake presets.json file. And this is all great, but there's a lot of benefits with using CMake presets. So it saves a lot of time because only one developer who's creating a CMake preset has to do the work of adding it to your CMake presets.json file. And it allows for multiple different build directories and generators. So you can have different build presets, for example, specified, and you can toggle those easily within a CMake project. This simplifies maintenance because there is a simple one file stop for you to look at any of your presets and improves consistency. So if you want to toggle something, if you want to change something, it changes it for everyone across the CMake repository, and it really just ensures that consistent build environment, and you don't have to have that wiki of how to build and compile your code. This overall consumes less manual brain power of, again, repetitive work, running commands. It gets you to that running your code in your IDE much faster, especially with CMake, which has a lot of convoluted steps at times. A lot of IDEs actually have really great integrated support for CMake presets, which makes it really easy if you don't want to keep referencing documentation to get started and configure your code with a CMake preset. You can always use the command line to call your presets, but it's just an easier way to have it integrated. In this case, we're looking at Visual Studio, but I know a lot of different IDEs have rich CMake preset support. So all you need to do is in Visual Studio is right-click on your CMake presets.json file. And as you can see, there's add configuration, add build preset, add test preset. And we're going to select a Windows preset. And at the bottom of the file, it'll just create a skeleton of my new configuration preset, and I'll just retitle it and save, and it'll rerun the CMake cache, and I can retarget it from the dropdown up top and then use that to build my project. So it's all dynamic. It allows you to change it in real time. It allows you to target it in real time and use that to configure your code. And it's really great in that regard. So you don't have to think about the skeletoning of your presets, for example, and it does a lot of that work for you. And this is all great for any of my build, configure, and test commands, but I also have to manually manage my library dependencies a lot of the times. And that involves me having a package manager and ensuring I install the right bits and install the right packages for my project. And this can also create an inconsistent build environment. So what's really great about CMake presets is you can actually invoke VC package from it, and that will then create a one-stop file for you to have all your package dependencies. So all you need to do to invoke VC package from your CMake presets is download VC package locally and then specify the file path to your VC package file. For example, in Windows, this is where it would output C VC package scripts build systems VC package.cmake. And then you'll just create a simple VC package.json file with any of your library dependencies. And what's really great about this is then you can commit that VC package.json file back to your repository. And then anyone who is working on your CMake project just has to clone that repository, download VC package themselves, ensure that it is going to the right VC package path, in that you didn't move VC package to a different location. And CMake will invoke VC package and download the correct dependencies that your project needs. So it's really great and eliminates, again, a lot of that manual work where things can break. So it's a declarative VC package.json file. There's support for all OSs. So if you're targeting Linux, it's going to download the right triplets for that. And you can share it easily with others because there is that single file location, and all you have to do is modify one line of code to ensure that you are invoking VC package from your CMake presets. It also tailors based on what your build configuration is from CMake and automatically installs missing dependencies. So it basically works both ways in that way that CMake invokes VC package, but VC package checks on your CMake and makes sure that there isn't any missing dependencies that you have. And that way, out of the gate, you don't have to do a lot of that library management that can be so painful. So we can take a look at an example of CMake Presets and VC Package both in action. So here we have a simple application. It takes those dependencies that I listed earlier, so SDL, SDL image, and that provides a rich image support with this application. And what it is just to set the stage is you type in down and it lowers you down a ladder. And we'll see that with simple tweaking of my CMake presets that the application will just work within Visual Studio. So it's really great in that regard. And so I just have the CMake toolchain file to my path where I downloaded VC package. And then I navigate to my VC package and I have all my different library dependencies. And I'll just use that configure preset to target my application. And it'll just build and download any library dependencies if I'm building for the first time and ensure that everything is up to date and working properly in case I have anything funky going on with my machine. So it'll just take a second to spin up and you'll see that my application loaded and it works perfectly fine. So I lower myself down the rope, lowers myself down the rope. And yeah, it's basically a 2-file stop. So CMake presets and vcpackage.json. And that way you have that consistent build environment and eliminate a lot of that manual work, a lot of that manual sharing. And that way we can all just work on our code base without having to ping other coworkers or revisit documentation. And it just creates a consistent developer environment. So now that we have accessed our code base and we can get that build, we're still hitting some issues and we want to be able to contribute to that code base now that it's all built and we've set up our machine perfectly fine. And Alex is going to take over and talk through some of the ways we can contribute to these code bases.
Yeah, so as Sinem said, we've walked through, there's a million ways to set up, there's a million ways to get access to the code base, but now how can we actually make changes and also learn what's actually happening? Why was this code base built the way it was? And so the best tool that we use internally that's super helpful is the live share extension for VS Code, or it's also built into Visual Studio. And what live share is a tool to kind of start remote sessions. And this is not just a screen share of your code. It's actually a way that people can see each other's code with their own settings still enabled. So like those experienced developers we talked about, where you have your own preferences. For example, you only code in Visual Studio. You can still screen share a code base, your code base to someone else, and they can do it in whatever IDE they happen to use. And so this is super helpful for pair programming, code reviews, technical interviews, and works with any programming language because it's just integrated into Visual Studio and VS Code. So it works for C++, but also other languages. And all you do is, we're about to show you a demo in a second, but all you pretty much do is you start a session as the host and you get a simple URL and you just send it to everyone that you want to join. So up to 30 people, and they can just join you. As the host, everything stays on your machine, even though they get access to your machine and they can navigate 2 different files in your code base that you're sharing with them. And you can also give them access to also run, to debug with you. They can also run commands in the terminal with you. Giving them access like this, as soon as you end the session, they stop having access to any files on the machine. Which helps keep people from, for example, you then create a GitHub code space and accidentally give someone permanent access to your code base where they can make changes. No, this is temporary. And and it's like you can either do it through a command, something in the command palette. You can do it through like this handy button that we're about to show you in VS Code, where it's just a free extension to use. So let's take a look. And so in this demo, what we're about to do is I will be in a code space because, I was trying to work on this locally. It wasn't building. It's just a lot easier to work in a code space. And so I have my code. In this case, it's 2048. And I was playing around with that, running into some issues that I'm about to show you. And then Sinem comes in to help me. right now we are inside a code space, and as we've discussed previously, these are super helpful for sharing code. And this time I'm trying to create this game 2048, which you've probably heard of, and I'm trying to finalize some strings, do all these different things, but I'm running into a weird issue. So I've already built, and now when I run it, I see the game, everything's working as expected. However, whenever I play a new game and I say I want a 4x4 grid, I can move everything around correctly, as you can see, right? It combines. But whenever I try to save the game and I press Z, it says no saved game found, starting a new game. That doesn't make any sense because the more I've debugged it, it's actually saving the game, but this just seems to be incorrect. So I'm not really sure what's happening here. And it would be really useful if I could actually talk to one of my coworkers and debug this together. So let's exit out of that. And the best way to do this is with an extension called Live Share, which, as you can see here on the left, you can just install really easily. I've already installed it. And to activate it, all I need to do is on the left, press this little icon and then click share and send this link to a coworker. So I've already been messaging with Sinem and she's down to help me. So let's create a link. And I'm going to share that link with her.
All right, so I received that link, and now what I'm going to do is navigate to File and Join Live Share Session. And then what I'll do is paste in her link and select Join, and it'll bring me to her code base that is in code spaces, and it will sort of show me her code, and I'll be able to do different functions like find all references or go to definition, and it'll all be powered by our code space, but I'll be able to reference all her code independently and edit it. So I'm seeing that you brought me to these two prompts. One is game state now saved prompt, which seems like the correct one that you want to output. And that one is the game board no saved error prompt, which is the no saved game found, which is the one that's being outputted right now. Since this is the correct prompt, I'm going to copy this. And then I'm going to go ahead and look at the error prompt and find all references in the code for it. So I'll right click and find all references and see if that's being referenced somewhere where it should not be. So now that it's loaded, I notice that it's referenced in this file, and it's also referenced in game.cpp, which is your main game file. So if you want to take a second and follow me, I went to the game.cpp file and I see that you are calling it when you want the game to be saved. So that seems like you have the right state, but you're outputting the wrong prompt. So I'll just copy in the right one. And I'm wondering if that fixed your bug. So can you go ahead and rerun your application and see if that worked?
Yeah, let me take a look. Okay, so let me rebuild this. And that looks good. So now all I need to do is rerun it. So if we go under the play button here in the status bar, this looks promising. We just create a new game. We make it a 4x4 and we move different numbers around. That looks good. But now what about the save functionality? Yeah, that fixed it. So now the game's been saved, all the text is correct, and it's time to take a break. So that sounds good to me. Thank you so much for jumping in and helping me.
Yeah, thank you for inviting me to this session. It was really productive. And if you want to go ahead and stop the live share session, then I'll be able to no longer have access to your code base, so you can continue on freely.
Exactly, yeah. And then I can keep playing with the game, making adjustments here. So I just have to press stop collaboration right here. And the session's ended. And now Sinem does not have access to any of my code anymore. So that was
all
it.
Right.
Thank you so much. Bye-bye.
All right. Bye.
So that was walking through live share, and that is just literally to create a new session. You just click on the button, share the code, off you go. But now, and so that was more of a way of you ping your coworker, join a session really quickly, and can debug whatever's happening in the moment. However, you're not always in the same place. So for some more asynchronous ways to share code, I'm sure you've all heard of GitHub. We've discussed it at length at this point. You've probably used it before. But there's been a lot of exciting updates for the Git integrations in VS and VS Code in the last couple of years, like multi-repo support, being able to edit three-way merges in VS Code more effectively, and a lot of just basic functionality that makes it easier on a larger scale to work with multiple people on one team in the same repo. Also, for example, they added profiles recently to VS Code in the last couple of months. So you can have multiple different profiles in GitHub. So that's one way to do it. And then what I would say is less well known is everyone's using GitHub, but there are actually GitHub integrations for both Slack and Teams. And we internally use Teams, but for both of these, the integrations are super helpful because you don't need to navigate to the browser every time, which I know that I always have 1,500 tabs open for different GitHub repos and different issues and different things we're discussing on the team. So what you can do is pretty much have in Teams parent cards that show your latest PR status. And then you can get notified for those PRs, for specific branches, for commits to those branches, for issues. You can even, if you have customized issues in GitHub that you like to track, you can have those show up directly in Teams. And then also review code changes. GitHub links actually show you what the GitHub if it's attached to an issue, for example, it actually shows you parts of the issue. And then all of this is the same for Slack. And I would say for Slack, they even let you customize notifications even more for when you're mentioned, or only specific instances when you're mentioned. And as you can see on the bottom right, you can also have like threads, and you can either have separate channels or entire threads that keep track of what the most recent state is. And both of these have been incredibly helpful also because you can create issues from Teams or Slack rather than having to navigate directly to the browser experience. So when, for example, your team lead's messaging, hey, we really need to create an issue for this new feature, you can just, I know on Teams, you just click on the 3 dots in the corner, and then it automatically creates a GitHub issue for you using the message that you pinned it to as the text and the description of the issue. And then it also links to your actual Teams conversation you had. So if you ever say, wow, none of this description makes sense, you can just go to the actual conversation you were having. So that is a really great shortcut that's super helpful and just makes it a lot more streamlined. So now we've talked about new hires, you've set up your machine, you can access the code base, you have potentially pinged every person on your team. Potentially they're not answering you, maybe they're in meetings, maybe they are busy doing their own thing. So this is where the question becomes, what do you do then? Because you've tried to access the documentation and the documentation might be a little outdated or not have the specific answer you want. And how can you sort of brainstorm still move forward? And so this is where GitHub Copilot comes in. And GitHub Copilot creates AI-based coding suggestions, and it's available in VS Code, Visual Studio, with JetBrains. So there's a bunch of different ways to use it. It's not limited to Microsoft products. And what it will do is pretty much you're typing in your file. Let's, for example, in VS Code. As you're typing, it will pick up what would logically make sense as the next step. And then in gray, suggest what that either code snippet, line, even entire function could be. And so once you just press tab, it adds it all for you. And this has been found by most developers, all developers are using it to be incredibly helpful. And as of March 2023, so last month, Copilot published that 46% of developers' code files on average are written by GitHub Copilot. And the developers using it on average code 55% faster. And this is because it can just generate so many different functions and code snippets for you. And it just makes it a lot easier to write code from scratch, where it can help you, for example, if you create a declaration, it can help you create a definition. And the most interesting thing I find is that can learn your code habits over time for the better or for the worse. This is where you hope you have good coding habits and it doesn't learn anything bad from you. But it can learn your code habits over time, so it can tell like how you usually lay out your files, how you usually make changes. And it works in all languages. It's integrated into the GitHub ecosystem. And if you're curious, because this is the whole AI world, it was trained on Codex, which is one of the code-focused descendants of ChatGPT 3. But GitHub Copilot has been available for a while. This is not as super new before this whole AI wave has come in the last couple of months. But with all these changes happening in terms of collaboration, they've actually released a new Copilot X, which is currently in private preview. And that's really interesting because they've added a lot of new features. So let's talk about that in a little bit more detail. So GitHub Copilot X, as we said, the regular GitHub Copilot was trained on ChatGPT 3. As we all know, there is ChatGPT 4. GPT-4 is available now, and that's what this was trained on. So it gives more accurate suggestions, but also you can actually ask it through chat, which we're about to show you an example of, and you can ask it through voice. So you're not limited to navigating separately or only getting inline suggestions. You can actually interact with it more. And the most useful thing that I've seen is that it can actually create pull requests for you, and it can generate those descriptions for a PR for you, and then list all the changes you've made and why you've made those changes, which is incredibly helpful because I've known many times where you get a PR, it's a like many line fix, you don't know where to start, why they made these changes, how they made these changes, and then you have to start, every reviewer has to start pinging the person who made it of what's actually happening here. But nobody likes writing paragraphs and paragraphs of description, so this can make it a lot easier where you can just parse through the PR description they've made for you, make sure it's accurate, and you're ready to go. And also it tends to make answers based on maintained docs. So this is not just any user anywhere has potentially miswritten some code at some point. No, the bias is towards maintained docs that are actually being held up to date. And so this will provide more accurate information. And the Copilot X can explain code blocks, it can explain unit tests, it can potentially help you write unit tests and tell you where our gaps are to create new unit tests and create bug fixes. And there is also a beta for it that lets you use it through the CLI only. So that's where this is really great and useful. And this is an example of, I think the formatting's been messed with a little bit, but that's okay. You can see on the left here, Sinem has a whole, some code she's working on. And so on the right, this is what the Copilot chat interaction would look like. And as you can see, she's asking, so what does this function do? Can you explain to me? And it starts explaining what the different variables do and how it interacts. And then you can also say, what does this class look like? Help me look for bugs in this. What would be a good way to test this? And so you can ask it a lot of different questions. You can even ask it to explain entire code bases to you of how different files interact with each other. Yeah, so and the thing with Copilot X, which is the one that includes Copilot Chat, Copilot CLI, all of those are in private preview today. So they are not publicly available yet, but if you sign up using this link, you can get added to the waitlist to get early access, which is where we got all of our, where we got the screenshots of how to chat with it and everything from. So, yeah. So this, so let's pull it all together. We're almost there. In terms of collaboration, we talked about the fact that, okay, collaboration has fundamentally changed. The issues that we were seeing is it's between new hires, and experienced developers, and there are some issues that all employees share, and they're all working on these code bases together. And some of the key problems were streamlining the new hire setup. And for that, you can use GitHub Codespaces, which are super fast to spin up, and DevBox, which help you customize different access points and go through Azure directly. And then you ran into the problem of it's hard to share code across your team. And that's where you can share presets in CMake and also VC package, which you can incorporate into CMake. And it can be really difficult to contact coworkers or contact coworkers remotely, synchronously, asynchronously, which is live share is the synchronously, where you can just call them really quickly, create a session, talk about your code, talk about, they can help you debug, use your terminal. And then also GitHub integrations to help make it easier to kind of add a code flow to the different messaging platforms that you are using. And then also, whenever a coworker is not available, you can play around with GitHub Copilot, ask them a couple questions, and see what they say. So, yeah. Also, we do have a bunch of other sessions by some of our coworkers at ACCU on Friday and on Saturday. And if you're more curious about the whole VC package and having dependencies, the best talk for you to go to would probably be the C++ dependencies don't have to be painful talk from Augustin, where you kind of deep dives in how to use a VC package and why you should be using it and how it can be helpful and how you can optimize it for yourself.